Okay, so in the first part of this video, I'd asked you to try number 8 on your own. So let's see how you did. All right, so it says a jet is flying at a speed of 526 miles per hour. The pilot, so here's our jet right here. The pilot encounters turbulence due to a 50-mile per hour wind, blowing at an angle of 47 degrees as shown in the accompanying diagram. Okay, so they want you to find the resultant speed of the jet to the nearest tenth of a mile per hour. All right, so first thing we're going to do is we're going to make this into a parallelogram. And if they want you to find the resultant speed, they're looking for you to find this diagonal that comes out of the two original forces. All right, so let's just first label everything we know. All right, so if this side is 50, so is this side. I'm going to use, again, the bottom triangle, just like we've been doing throughout. And although this side's 526, I'm not using the top triangle, so I don't have to write it here. I mean, if you want to, you can. All right, now, this angle of 47 degrees, what that does is that helps us find this angle right here, because these two angles in a parallelogram are supplementary. They add up to 180. So if you do 180 minus 47, it gives you 133 degrees. Okay, now they're asking you to find the resultant speed of the jet. So the resultant is our diagonal, so what we're looking for is this x right here. Okay, so we know this side is 526. We know this angle is 133. We know this side over here is 50, and we're looking for the resultant. All right, well, if we're working with three sides and one angle, there's law of cosines. So I'm just going to plug this into law of cosines, and you can see how you did. Okay, so we wind up getting 561.3 miles per hour. So that's what this side of our triangle is. I'm just going to put it on there, 561.3. It's kind of hard to squeeze it, sorry. All right, now, the second part, I'm going to just call that part B. We'll do that over here. Says to use this answer, so use this answer of 561.3 to find the measure of the angle between the resultant force, so here's our resultant force, and the wind vector. So here's our wind vector. So really what we're looking for is we're looking for this angle right here. Now if we were to look in the blue triangle, we know that this angle and this angle are alternate interior angles, so they're the same. So in our blue triangle, this is the angle that we're looking for. All right, so, I mean, you can use law of sines or law of cosines. I use law of sines because I find it quicker, but it's a little faster. So with law of sines, you could do this side that we know over sine of the angle we're looking for equals this side that we just found over sine of the angle across from it. So I'm going to do that, and then you can check your work. Okay, so they wanted you to round your answer to the nearest tenth of a degree. So when I did that, I got 43.3 degrees. All right, if you guys have any questions on, the forces that we did today, I'll be back on Monday, and we will go over forces again in class on Monday. Have a nice weekend.